This lab activity is some preliminary skills that we're going to use a lot for future activities in this term. There are really two big categories that we're going to deal with. The first one is curves and tangents of curves. And by a curve, I mean any, we're going to be dealing with two-dimensional curves, so I mean any connected line or shape that you can draw in 2 dimensions. So this is a curve, this is a curve, even a straight line is a curve, even though it doesn't curve, but any of those 3 things are what I'm talking about. And the crucial thing that we're going to be dealing with over and over again is visualizing the tangent of a curve at a point. So let's say that this is the point we care about on this curve, this is the point we care about on that one, and this is the point on that one. And so what's a tangent line at these 3 points? In order to draw a tangent line, the way to do it is visualize or draw, if it helps you, 2 points very nearby to the point you care about. Then draw a line that connects those 2 points and continue that line. And that line that you drew is the tangent. On this one, 2 nearby points are here and here. So draw the line between those, continue it, and that's the tangent line for that one. In this case, those are the 2 nearby points. Draw the line through them and continue it, and you can see that the tangent line at any point on a line just gives you that line back. Okay. We're going to deal with 2 different types of curves. Even though they can look exactly the same, the way you approach them is going to be different. The first one of these is when this curve represents a graph. And in this class, that graph is going to be a position versus time graph. We haven't talked about what position is or how time relates to it or anything, but for us, it's going to be position versus time graphs for 1D motion. And 1D motion is just motion along a line. And then the second thing that we're going to deal with is when the curve represents the path of an object in 2 dimensions. So right away you can see that you have to be very clear which one of these you're dealing with, because they're 2 totally different things. Are you dealing with 1-dimensional motion, or are you dealing with 2-dimensional motion? You obviously can't treat those the same. And then the second big category that we're going to be dealing with today is ranges of vector directions. This one's going to be pretty simple. When I say vectors, for now, just think of those as arrows that show a direction. We'll talk later about what vectors are mathematically. Okay, so let's first get into curves and tangents. So I mentioned how to find the tangent of a curve. What are we going to do with this in the case that our curve represents a graph? If the curve represents a graph, what we care about is the sign, the plus minus sign of the tangent line. Okay, so remember that this line has a positive slope, a horizontal line has zero slope, and this line has a negative slope. So that's what we're going to be looking for. Don't do that. Okay, so if our graph is this, and we're looking for the sine of the tangent at that point there, we'll draw the two nearby points, draw the line through them, and you can see that that tangent line has a positive slope. And so we know that at this point, the tangent to the graph has a positive slope. So that's what's going to matter when we're dealing with graphs. Now, if that same exact curve could represent the path of a two-dimensional motion, so let's interpret it in that case. So I'm going to just try to redraw that basic thing. So what if this is the path of an object in a two-dimensional space? It doesn't represent, it's not a graph of a one-dimensional motion. It actually represents the path in 2D space. Well, first you have to know which way the object is going. So let's say that the object is going from the right side to the left side. And what we want to do in this case is draw the vector, the arrow, that's tangent to the path and in the direction of motion. Okay, so I'll choose the same point. And we're going to start by visualizing this same tangent. Okay, so there's the two nearby points, and then the tangent line goes, is a continuation of that tiny little line I've drawn. But instead of drawing that line now, I want to draw the arrow that's parallel to that line and in the direction of motion. You can think of it as so I could draw an arrow that's down and to the left, or I could draw an arrow that's up and to the right, parallel to that little green line. Which one do we want? We want the one that is in the direction of this motion, and so I'm going to draw it like this and put an arrow on it. Okay? So in the cases where we're interpreting these curves as position versus time graphs, as graphs, what we want is the sine of the slope of that line. When we're interpreting it as paths of objects in space, what we want is the direction of the vector, of the arrow, that's tangent to that path in the direction of motion. Okay. Then the second category of things you're going to be doing in this lab activity is coming up with a range of directions between two given vectors. So let's say our two vectors are this way and this way. And for now, we don't care about the lengths of those vectors. We only care about the directions. So what's the range of directions in between those two? In order to do that, take one of those two given vectors and put its tail at a chosen location like this. Now take the other one and put its tail at the same location. And the range of vectors in between those two directions, the range of vector directions, is all the vectors along the shortest arc from one of those to the other one. So the shortest direction from one to the other one is in here. And so we're considering all of the possible vectors, the infinitely many directions in between those two. Okay. So what that means is the range of directions between these two is all of these, and it doesn't include any of these, you know, like this is not in that range of directions. Okay, so really with those three skills, you have everything you need in order to do this first lab activity. And later on, as the term goes on, it'll start to be clear why these three skills are important to us.